What a pleasure to be with all of you this afternoon to talk about carbon dioxide removal. My name is Benjamin. I'm the founding partner of Climate Tech Venture Studio, focusing on carbon management, carbon removal, and decarbonization more broadly. Super excited to have an amazing panel of speakers to talk about carbon removal with us for this session. I will introduce briefly all speakers. We're going to have a conversation together, and then we'll have 10 minutes at the end of the session to answer to your questions. So please remember to use the Slido app that you should all have access to, and you can ask your questions, and we will take them at the end of the session. So first, very happy to have Bryony Worthington. So Bryony is a crossbench member of the British House of Lords, and she's a long-time environmental campaigner. She was one of the lead authors of the 2008 UK Climate Change Act, and she's been leading and supporting many climate non-profits focusing specifically on carbon removal and how to abate emissions. Second, we have Clea Kolster. Clea is a partner and head of science at Lowercarbon Capital, which is an $800 million VC fund that invests in technologies that reduce emissions in all sectors and that remove carbon from the atmosphere, and also buy more time to tackle the issue. She has a PhD in chemical engineering from Imperial College, focusing on carbon capture and storage. Julie Gosalvez, she's the chief marketing officer of Climeworks, which is one of the early pioneers and leaders of direct air capture, and she leads the company's effort to bring to market very large-scale carbon removal to both enterprise and individual customers. Last but not least, Mitchell-Larson is the launch director of Carbon Cap, which is a brand new climate NGO focusing on making Europe a leader in carbon dioxide removal. He's also a researcher on carbon removal at Oxford University, where he co-authored the net zero principles, the principles for net zero aligned offsetting. Eli has also worked in clean tech and previously collaborated with Carbon Direct, which is a carbon removal VC fund. Super happy to have you all for this conversation. So I'd like to start from the top and maybe start by explaining what is carbon dioxide removal and why do we need it in the first place, because there's a lot of confusion between carbon removal, carbon capture, decarbonization. Bryony, I think you're the perfect person to start. What is CDR and why do we need it?
Thank you very much. Carbon removals is really a term that describes the drawing down of the greenhouse gases that are currently in the atmosphere and the locking of those away in safe ways. And why we need it is because at the moment, parts per million in the atmosphere are at record levels. They're at levels now that are higher than any time over the last 4 to 5 million years. And the last time they were this high, temperatures were extraordinarily higher. On average, you saw temperatures in the Arctic that were over 10 degrees warmer than previously under those concentrations. And sea level rise at that time was also, the seas were 10 meters, over 10 meters higher than they are today. So at that level of concentration in greenhouse gases, we are taking really, really big risks with our atmosphere and the effect that will have on our society. So we focus on temperature targets in the Paris Agreement, but that's a trailing indicator. What matters is the concentrations of greenhouse gases in the atmosphere and how high they are. They are way too high for us to feel confident or safe. So we need to draw them down. We need to totally stop adding to them, and that's a totally different story. But this story is about what we do about what's already up there, what we know will be released, and what we do about it.
Thank you, Bryony. Clea, do you want to react? Why do we need carbon removal, Clea?
Yeah, absolutely. I mean, Bryony said it very well. But in addition to that, I just add a kind of shocking number that about 50% of the emissions that we've had in the since the Industrial Revolution have come about in the last 30 years. And that is an unprecedented. It's an unprecedented concentration, but it's also an unprecedented rate at which we are increasing that concentration. So 100%, we need to reduce emissions as much as possible, as fast as possible. But even if we do that tomorrow, we still need to remove CO2 from the atmosphere. And that's what we're here to talk about today.
Thank you, Clea. Eli, I'm turning to you because Carbon Gap aims to be like one of the leading advocates of CDR in Europe. So why does Europe need to invest in CDR? Why do we need CDR? Why is it important in the...
Sure, thank you, Ben. Just to build on what Bryony and Clea were saying, I think the great thing about, well, the positive thing about climate at this stage is that our goal is very simple. You know, ever since the Paris Agreement, we've agreed to achieve net zero. And carbon removal is really the net in the net zero. So we will still be emitting carbon in 2050 when we achieve net zero, but we'll need to be removing the same amount. Now, that's something that we kind of all collectively agreed to, but I think the climate movement and policymakers in Europe and in other regions might not have fully grasped that we need to do both things at the same time, right? We need to bring emissions down as rapidly as possible, and we need to be scaling up removals. And at Carbon Gap, we think that Europe, as a region specifically, can play a massive role in that challenge. One, setting standards that define what constitutes good carbon removal, because we'll talk about today there is good carbon removal and there's bad carbon removal. Two, really supercharging innovation. There's so many different ways to remove carbon from the atmosphere, and we need to put lots of money into exploring what ways exist and what's going to work. And finally, Europe is one of the few places in the world that really has such strong political will to stop climate change, and that's really going to require something like a deployment incentive. So paying over a long period of time, people to do the activity you want. We tried this with wind and solar. Now we'll need to do the same for carbon removal.
Thanks a lot, Clea. I think we've established a few ground truths here, which is first, carbon removal is about removing CO2 from the atmosphere and not from point source emissions. So that's a clear difference between removal and capture, which in certain languages can be confused sometimes. And it comes in complement to reducing emissions, which is absolutely critical, and we need to do both, and to do both in very large scale and quantities. So I'd like to switch gears and go straight to examples of what CDR is and how it works. And I think what a better example to start that Climeworks. So Julie, can you tell us more about Climeworks and direct air capture and how it works?
Sure. So basically, Climeworks was founded 12 years ago when at that time it was already evident that there was too much carbon in the atmosphere. And our two co-founders decided to focus on a technology that would enable to remove and capture the CO2 out of the air, right, directly, as you said, and not from point source. So direct capture is really at the core of what we do, and that looks like big machines that are filtering the air. And thanks to a chemical reaction with a solid solvent, it basically locks the CO2, the carbon, then air-free CO2 is emitted, and we are able to capture the carbon in a very pure way. Then it can be either upcycled and reused in different ways, either as a raw material in greenhouses, as a natural fertilizer, or also in carbonated drinks, for instance. But more and more we've been focusing on the pure removal, meaning combining this direct capture with storage. And we recently opened the first and largest plant doing so in Iceland. We're here surrounded by lava, so that's very emblematic, where basically in Iceland, through our partnership with Carbfix, a local company, then the CO2 that I mentioned earlier is then mixed with water and pumped deep underground, where it mineralizes rapidly, so roughly under 2 years, at the contact of the basaltic rocks that has holes in it, and then fills it, so literally the CO2 is turned into stone, and as such permanently locked away for thousands of years. So that's basically how DSC, direct capture, is applied to carbon removal, and for us delivering this need that we're talking about.
Right. So, and you insisted on the fact that this is an example of what you call pure carbon removal, in the sense that it combines the removal step with the storage piece in order to deliver negative emissions, durable negative emissions. I'd like to turn to all of you to maybe give a few other examples of other categories and other pathways for carbon removal, and maybe to find out like how they compare with each other. Maybe Clea, do you want to start and give an example of some of your favorite pathways for CDR?
I'm not great at following those kinds of rules because I like a lot of the pathways, but maybe I'll highlight the perhaps elephant in the room, which is planting trees has long time been considered a form of carbon offset or even carbon removal in a lot of instances, but that is not enough. It's not enough because because of climate change, we're at risk of multiple wildfires, and it is not a source of permanent carbon removal. And also it doesn't last for a very long time. So the kinds of things that we need to focus on in carbon removal is duration, additionality, ensuring that what you're doing is providing an incremental reduction of carbon, and I think I forgot my last point, but that it's resource efficient. Sorry, that it's a solution that can become accessible to countries, people in countries around the world to implement as part of their climate strategies.
Right, so that's a great answer to like a common remark we often get when we speak about CDR, which is, oh, but nature has already invented the best carbon removal machine, it's trees, and we just need to plant a lot of trees, and it will be enough. And your point is that, yes, we need to plant trees, but it won't be enough, and we need many other pathways to do that.
Well, we need to make sure that we don't chop down more of our forests, that's for sure, and maintain our ecosystems. But yes, planting trees is not a solution for carbon removal.
Yeah, definitely. Do you want to, does anyone want to give an example of maybe like a pathway and a company that you like? Eli, I know there's one company in particular you wanted to mention.
Yeah, sure. I think what's nice about carbon removal, again, to simplify it, you have a sort of extraction from the air module. You have to have some way of taking CO2 out of the air. You do something with it, and then you store it. So every carbon removal technique has those three steps. And so although I completely agree with Clea that nature-based solutions are insufficient on their own, sort of using photosynthesis as a means of taking CO2 out of the air is really, really great. And so one company that I find really interesting, it's from my home state of Maine. It's called Running Tide. They're not the only company exploring this pathway, but they're one of the first. And it's a little bit wild. It kind of captures the imagination. They're actually using the power of kelp, so these very large macroalgae seaweed in the ocean, to take CO2 directly out of the ocean, because of course the atmosphere and the ocean are in equilibrium and the CO2 is exchanging between them. So taking CO2 out of the ocean is the same essentially as taking CO2 out of the air. But what they do with the kelp is so interesting. They grow it on these free-floating buoys, or buoys in British English, and they allow these buoys to float throughout the ocean and accumulate kelp, at which point the buoy biodegrades and the entire apparatus, including all the kelp that has grown and taken carbon out of the water, sinks to the bottom of the ocean, where, we hope, it will stay for eons, tens of thousands of years. So it sounds absolutely wild, but you spend a few hours with them and you're like, you know what? You're onto something. So there's so many creative ways to remove and store carbon, and that's just one that I found really compelling.
If I can just briefly note that, that in addition to what Eli mentioned, what Running Tide is doing, what kelp can enable, which is very exciting, is that actually you're sequestering CO2 at 10 times the rate that you would on land. And the duration of the storage, because the kelp is sunk to the bottom of the ocean, it is essentially stored in the sediment, which translates to a form of long duration carbon storage.
Super exciting. I love this pathway and this company. Bryony, do you want maybe to give an example? I don't know if you can pick a favorite, but what would be like one of your favorite like CDR pathway solutions companies?
Am I allowed a couple? I mean, just building on the use of nature, you can obviously have managed forests which are then producing timber for construction, and that is actually a really good store if you're not burning or allowing it to degrade and naturally and putting it into buildings infrastructure. That can be an effective store. So there are ways. I'm really interested in how we speed up photosynthesis, because it's a naturally braked biological process. It's really inefficient, and nature has designed it to be so it doesn't take over. But there are certain plants and trees that grow far faster than others. The empress tree is my favorite. It grows really rapidly within your own lifetime. Bamboo is another substance which is able to grow at scale and absorb fast. So I think we're going to see a whole interesting field of like, okay, what are the natural systems and how do we augment them? But if we turn to rocks, because I feel we should because we're surrounded by them, I'm really interested in enhanced weatherization or mineralization. It's peridotite rock absorbs CO2 naturally. And often it's co-located with rare earth metals or with copper. So you have mines that are digging this stuff out and pulverizing it. And that's a natural way of then enhancing the weatherization. So the mining sector started to realize they're sitting on a bit of a gold mine here, that they can use their tail minings to enhance CO2. So there's a lot of research going into that. It's an exothermic reaction as well, which means it's kind of energy efficient, which is exciting. And then just a last plug, if we're talking about DAC and direct air capture, where you're running these big machines, they need electricity and heat quite often. So I'm quite excited by the idea of co-locating them with nuclear power stations, because we're going to need a lot of energy to do this. And I think DAC plus nuclear equals a really good solution.
Great examples. Thanks a lot, Bryony. So we have a room who's full of entrepreneurs, investors, large companies. So I'm guessing some of them might be wondering, but who pays for this? Like, what is the demand? Who's going to fund something like removing CO2 from the atmosphere? And so Julie, Climeworks already has customers. So can you tell us more about who pays for carbon removal today?
Sure. So I think, you said it in the intro, we have two types of customers at Climeworks. And I'll start with one that's closest to my heart, it's like the individuals, right? 30 months ago, 2.5 years ago, we've opened our carbon removal service to individuals. And a few days ago, we surpassed the 10,000 people using the service, really showing that there is really a movement and a lot of citizens engaged into finding this as a solution. And of course, in terms of share of business, you might look at that as on a small scale versus the other side of the customer that I'm going to talk in a minute. But it's really inspiring to see how people are engaged in those issues, and it's a very important part of our business also into creating this movement. But of course, we do have a lot of also pioneering customers in that way. Started with Stripe and Shopify. We were among the first ones to establish policy, in-house policy, in terms of getting a price on carbon, or even kick-starting the demand in a very effective way, followed obviously by Microsoft and included into the great portfolio and RFP work that has been done. But we also have different industries. So The Economist, for instance, most lately we announced a partnership with Swiss Re, one of the global leader in reinsurance. I think one notable thing, and the trend that we see last week was about Square as well, partnering with Climeworks, is really long-term agreements, long-term relationship in terms of really establishing partnerships that enable the growth of the industry and the market. So I see really that as a dynamic between market and demand and supply in a way that's really going this into the long term. When we built Orca, so our plan that we launched in September, most of it, or when it was decided, most of it was kind of a goodwill from Climeworks saying, hey, we see some demand, but we will then create this supply because we know it's needed, and going to the industrial scale really fast is the name of the game in scaling up. And then finding more and more customer. And now we're looking at building a 10x plant, bigger in the coming years. But it's really important to have this pioneering customers also able to give this long-term commitment. I think that's really important.
Thank you, Julie. And really to make it clear for everyone in the audience, so these pioneer customers, these Stripe, Microsoft, Shopify, and others, they don't pay you to buy the CO2. They really pay you to permanently remove the CO2 and sequester it durably. And I think this is a very important point to stress.
And I think the two things that are maybe important for our audience to understand is we work with companies who have like really ambitious net zero and sustainability pledges. They're very often members of the SBTI, so Science-Based Target Initiative, and they always start by reducing. Right, so they have a very clear understanding that reducing emission is first, but also a very good understanding that we're not at the stage where we can reduce everything, and there's still a lot of sectors that are hard to abate. One thing, so that the unavoidable emissions have to be addressed immediately, and also that the historical emissions have to be addressed. And that's what Microsoft has very well articulated in their pledge by being net zero into 2030, and then by then remove the historical emissions. So I think that's really important into that. And the second part is really understanding that the scale up of the industry is really at stake now, if we want to be at the right dimension and the right time.
Very clear. Thanks, Julie. So Clea, when you hear that, does that make, like from the investor perspective, that makes the business case for CDR? Like, how do you see this demand evolving?
Yeah, absolutely. I mean, today we basically see that demand is far outstripping supply. Between the Microsofts, the Stripes, the Shopifys, the Squares, the Munich and Swiss Re's, there's very easily and quickly about $100 million that is ready to be deployed in carbon dioxide removal. Now, the supply, unfortunately, is not there. While Orca is a pioneer plant that's, I think, on the order of less than 10,000 tons of CO2 removed annually, which is fantastic, huge dent. It's the first one of its kind. But when we're talking about the numbers that Bryony mentioned earlier, and we are going to need somewhere on the order of 1 billion tons of CO2 removed in the next few years, and on the order of 10 billion tons annually removed by mid-century. Now that's, you can do the multiplication. That's a lot more than what we have today. So as an investor, we see this as a fantastic market in which we want to invest in new solutions that can provide that supply. And Microsoft, Stripe, and Shopify, they're currently willing to pay several hundreds, if not thousands of dollars per ton of CO2 removed. That's a pretty high price. And we talk about solutions needing to get down to below $100 per ton of CO2. Some might talk about a social cost of carbon that is measured somewhere between $50 and $100 per ton. I reckon that's probably a lot higher than that, and we're seeing that the demand is actually willing to pay those high prices. Now, as I mentioned earlier, we need that to be accessible for everyone and for a global population. So that's what we need to think about in terms of helping and bring down the cost, thinking about forward purchasing, which I think Climeworks has done a fantastic job at, and others, at putting up those tons of CO2 removed up for grabs before they're actually being done, so that you can actually start financing those solutions.
Absolutely. And so I'm guessing at this point, some of you in the audience, when you hear about companies paying to remove carbon from the atmosphere, intuitively you might associate that with offsetting. And offsets have not always had a good reputation, and there's many different types of offsets. And so I'd like to turn to you, Eli, because you worked on some very important work at Oxford University, focusing on a kind of a taxonomy or a framework, a mental model to see these different types of offsetting. Can you tell us a bit more about this, this framework and this work?
Yeah, sure. I think carbon offsetting gets a bad rap, and it deserves it. I mean, George Monbiot famously said, I think in 2006, that offsets are basically a form of indulgence, or that was his critique. It's basically something you buy so you don't have to do the stuff that's really hard, which is actually getting rid of emissions. So one thing we tried to do with the Oxford Principles for Net Zero Aligned Offsetting was to say, everyone's committing to net zero. I mentioned this earlier. That's what many of these companies that Clea is mentioning, they've made net zero commitments on a voluntary basis. And so if you want to be able to say that you are at net zero, it has a very specific definition in the scientific community. It is a balance of sources and sinks. It means however much carbon you put into the atmosphere, you return an equal amount of carbon back into the geosphere or biosphere, somewhere where it's safely stored. And so what we did was we tried to say, it's quite simple actually. There's two types of carbon credits. Credits that involve the avoidance or emission reduction, and credits that involve carbon removal. And by the point in time at which we're at net zero, so hopefully 2045, for some companies even sooner, by that point in time, you must be balancing all emissions with removals. So the percentage of your carbon credits that are removals needs to be 100%. So it's a fairly simple point, but what we wanted to say was that it's going to be a transition. There still are forms of carbon credits that are backed by avoided emissions or emission reductions, which might be really valuable things to finance. But I think the important thing to remember, in addition to the fact that these companies aren't buying the CO2 itself, they're buying the fact that the CO2 was removed and stored, the service. In addition to that, let's also remember they're doing this on a voluntary basis. It's coming out of their bottom line. And so I think maybe in the next section we'll talk about what we need to do to take that to the next level. But I think what we tried to do with these principles was just say, it matters which types of carbon credits you buy. And that's a journey you can go on. And as long as you're open and transparent and you're following things like the Science Based Targets Initiative and indeed the Oxford Principles, then you're going in a good direction.
Thanks, Eli. I'd like to focus a bit on numbers now and to do a reality check to get a sense of proportion of what we are actually talking about. And Bryony, can you give us like a sense of according to you, like, and according to climate models you see, how much carbon removal do we actually need? On which time scale? Like, just to give a sense of scale to everyone in the room.
So I'm going to answer that in a typically political way, which is not to answer the question you asked me, but to say something else. Because actually we don't know, is the truth. Because our risk, our exposure to climate risk is determined by emissions over time. And at the moment, we are believing that we're going to get to net zero by 2050. Quite frankly, that looks utterly impossible to me, standing here today. The NDCs that were submitted, the pledges to the Paris Agreement, added up to an increase in emissions of around 10% on current levels. To be in anywhere close to hitting Paris goals of 1.5 degrees, we need to see halving of global emissions within a decade. So that's a huge delta between what we know science is telling us about the risk and what we're prepared to do. So if you think that's the trajectory we're on at the moment, which is basically just almost business as usual, but not quite as bad, and we've got to get into this massive emergency response where we're seeing a huge falling off of emissions very rapidly at a global scale, not just in Europe, but everywhere, the chances are we're not going to make that. So that trajectory is what's going to determine the parts per million in the atmosphere and the risk we're exposed to, and that's what's going to dictate how much of this stuff we've got to pull out the atmosphere to get back to anything safe. So it's not you can't answer it, but what you can say is that it's got to be a hell of a lot more than zero, and at the moment we're close to zero. So we have to start investing now in anticipation that we're going to have this massive cleanup operation that kicks in sometime between now and mid-century, where we're starting to realize, okay, we've screwed this. We need to do something about it. And it will be driven by governments saying, this is no longer voluntary. This is something we have to do collectively to survive. And we've got to get ready for that now. Sorry.
Thanks. So you don't want
any numbers at all?
You don't want to give me a number?
No, I'm not giving you a number.
Anyone who wants to give me a number, like how many gigatons, or if you had to take a guess?
You gave a number.
Sure, I can reiterate the number, and I think just reemphasize the investor's perspective, which is, I mean, we often talk about 2050. That's what the climate models show. That's what the Paris Agreement has been involved with. But obviously, as a venture capital investor, I'm not necessarily expecting much around 2050. I don't know where I'll be in 30 years, but the market is coming in the next 10 years. And in the next 10 years, we see something like, honestly, I think it's going to be way more than a gigaton. But right now, the projection is somewhere around a gigaton, 1 billion tons of CO2 removed at that scale in the next 10 years. And that's just basically what you need as a plausible trajectory to then eventually get to something where you're at 10 billion tons of CO2 removed annually by mid-century. I think I quite agree with Bryony's point that it's really hard to put numbers on this. All I can say and reiterate is that the demand is there. Right now it's a voluntary demand. It does need to be boosted by government demand. But I think the voluntary demand keeps going up. So
10, I mean, it doesn't have to be a fixed number, but in the order of magnitude of like 10 gigatons per year by mid-century, from almost zero today, basically.
Just one last one is that since the Industrial Revolution, we have emitted a total of, and that's what, 170 years, we've emitted a total of 2,500 billion tons of CO2.
And around half of that's still in the atmosphere, right?
Yeah.
There's a natural absorption, but yeah.
So
we have a lot of cleaning up to do.
Yeah, Eli, do you want to react to that in terms of like the magnitude of what we...
I can try, but I love Clea's point, and I think all of us agree here that, there is this point that we've been just using the atmosphere as a dumping ground, and it's basically a justice issue. Like maybe 5 years ago, maybe 10 years ago, maybe 15 years ago, we could argue in our professional lives or in our personal lives that, this is an important issue, but not, the most pressing issue of our time. Well, we can't say that anymore, right? And so I would say, Bryony often says, when did the clock start? When did we start saying, well, we're responsible for this? Microsoft has said that for them, the clock started in 1975 when they started the company. But even if the clock doesn't start for you that far in the past, if you're happy with today's atmosphere, then we haven't been reading the news, right? Like even today, at 1.1 degrees Celsius on average, warmer than pre-industrial, we're experiencing a lot of terrible, terrible impacts on human and non-human life. And so I would argue that every ton of CO2 we emit from now until the point at which we reach 2050 is CO2 that we have to remove, which is a massive opportunity. And so, to put some numbers on it, today we emit about 50 billion tons of CO2 every year. And by 2050, if we do achieve net zero, most of the representative pathways from the IPCC say that we would still be emitting on the order of 5 to 10 billion tons. So that would be sectors that are very, very expensive to abate. Not hard to abate, but expensive to abate. And so that would say that by 2050, we need to be removing 10 billion tons of CO2 a year. And to put that in perspective, that's like moving a volume of fluids around, not so unlike the amount of fluids we take out of the geosphere at the moment in fossil fuels. So you have to imagine an industry that's putting CO2 back into the earth where it belonged, returning it back on that same order of magnitude. But of course, between now and 2050, how much CO2 are we going to remove? Well, the Energy Transition Commission says on the order of 220 billion tons cumulatively. So it's a huge number. It's a huge opportunity. It's a huge challenge. But ultimately, Bryony is right. The amount of CO2 we have to remove is a function of our decisions today. The faster we can reduce our emissions and stop putting carbon into the air, the less that we're on the hook for removing.
Brilliant. So basically, we need to build an industry like the size of the oil and gas industry in reverse in like 3 decades or 4 decades. So it's pretty massive.
Which is kind of fortunate because they're not going to be allowed to dig out oil and gas, right? So what should they be doing? They should become a waste disposal industry and be responsible for putting it back. And people say, oh, it's just going to be too complex, it's too large. Look at what we've achieved as humanity in digging stuff out of the ground. It's not beyond imagination that we could do that in reverse. But we'll need incentives. And the fear I have is that the people who run our fossil fuel industry, they're going to have to be forced to do this. This is not a business model that they're used to or want to get involved in. So governments are going to have to step in and create that industry. In the same way that we built, infrastructure for sewage in the Victorian era, government stepped in and said, there's a collective problem. We need to regulate this, and we need to create incentives for companies to do this. Left to their own devices, the oil and gas industry will not touch this with a barge pole. It's not anything close to what they want to be doing with their time and resources. They're going to have to be regulated.
Absolutely. And to reach this kind of scale, we're going to obviously lower and really decrease the price per ton of CO2 removed. And so obviously planting trees is still pretty cheap today, but for all of the other pathways, it's still pretty expensive, but it's falling rapidly. So I'd like to turn back to you again, Julie, to maybe tell us more about how it's been working for Climeworks. What's the price per ton of CO2 removed for Climeworks today, and how has it been evolving over time? Where do you forecast it to be in the future?
Yeah. So I mean, definitely, we said it needs to be at some point accessible, and I think the intention is to create a virtuous circle as fast as possible, right? The more you scale up, the more your costs go down, the more your costs are lower, or the lower your cost, then the bigger the demand, and then the better the supply. So we have a couple of decades to do that, and just taking a perspective for now, the company has been existing for 12 years, and for the first 7 to 8 years, it was really about the technology and making sure that we're coming from milligrams to grams, to kilo, to tons, extracted in a very reliable and safe way. I think from a potential standpoint, what we see, I agree with you, Clea, that probably the cost or the price tag that's going to be on carbon is roughly around $250, more than 150. I find it a bit optimistic as a prediction, and that's where we see, that the Climeworks will be able to play. For now, obviously, we're far away from that, but we have a lot of history when we look at solar and wind in particular. We've been able to decrease cost about 85 to 90% over the last decades with these dynamics, right? That we were talking about before, and that makes us confident. One thing that makes it very confident is that the way the technology of Climeworks is conceived is a very compact and modular way, in such very inspired from solar that has been very successful. So not only it's easy to deploy, deploy or easier to deploy in different locations that have certain properties, but it's also then getting in efficiencies. So the capture rate, the energy efficiency rate, all of this can be optimized from a process way. So that's why it was so important to bring it to life very early, because you have then a lot of ways to optimize it that come into play, and you also know what you're facing to. So we're working now on the roadmap from a customer standpoint demand, but then also expanding. So 10x plan, very, very fast. So.
Thank you, Julie. And I really like that you made the comparison with solar, because I think it's a great example. And like often in conversation about climate tech, when an emerging solutions is very expensive, which is often the case at the beginning, sometimes it's easy to dismiss it on the basis that it is expensive today. But when we look at solar, when we look at lithium-ion batteries, when we look at hard drives, we look at DNA sequencing, like all of that used to be super expensive, and the cost fell very rapidly with what's called learning curves. And so, Clea, as an investor, I'm guessing some of the companies you invest into, they have solutions which are very expensive. So you're also betting on these learning curves to fall over time, right?
Yeah, 100%. And again, I mean, carbon removal, just like any other solution, does not exist in silos. They are various technologies around carbon removal are benefiting from improvements, technological improvements in other industries. And to your point, Benjamin, I mean, one computational power. I think what's most inspiring about the founders and innovators that I get to meet every day is that they start with very little, and the fact that they are able to today, buy a DNA sequencing package for a few $100s, be able to run some very novel geometries and very complex algorithms on a cloud computer or some server that's somewhere else that they don't need to pay for a very little amount. The fact that they have access to new materials, the fact that you have more access to 3D printing, and that you can get things done that are less labor intensive. All of those things combined are being applied to the carbon removal industry. So we're seeing some very exciting innovations around also just iterating on prototypes and hardware. Charm Industrial, for example, is a company that we work with based in the US that are utilizing the kind of photosynthesis-enabled route where they take biomass waste and burn that and convert that to a kind of bio-oil and store that deep underground, and that form of carbon is a form of carbon stored. But they've basically been able to remove on the order of a few thousand tons or about 5,000 tons, thanks, of CO2 in less than 2 years. And that's the kind of iteration speed that is very exciting to see around carbon removal. You also have the advent of electrochemistry, which is enabled by computation and new materials. That means that we have new ways of scrubbing CO2 from the atmosphere that might not require heat, but can be reliant on electricity, which is also a lot cheaper today than it ever was before, with solar PV costs going down, battery costs going down. So all of these, everything within the technology ecosystem is enabling also of carbon removal. So to the founders out there, there are so many backgrounds and disciplines that can be applied here. So I would highly encourage you to work on this if you're so inclined.
Thank you, Clea. And so in addition to all these pioneers and innovators developing these new technologies, my question is like, what else do we need to go down these learning curves and to reduce the cost and to increase the supply? And I'd like to turn to you, Eli, about like what's the role of policy in this? Because I'm sure we have a few policymakers in the audience or remotely, and yeah, policy has a role to play. And can you tell us what is this role?
Yeah, I mean, just going back to the solar example, we went from millions of euros per watt on the Voyager spacecraft to a couple cents. And that didn't just happen, right? It happened because a few countries stepped up. They were entrepreneurs. Germany, Japan, and of course China in building all this stuff. But Germany spent billions and billions of dollars of the public money, and they didn't necessarily benefit from that in every way. They actually contributed to much of this downcosting, and they did it through what we call a scaling incentive or a deployment incentive. And what that is a fixed price that's paid for every unit of something you generate over a long period of time. So every kilowatt hour of solar that you generate on your rooftop in Germany for a long time, you were paid quite handsomely. And the project developers tell us again and again that it's the same for carbon removal. If you're going to put a bunch of money into a project, you really need that guaranteed offtake. And that's where policy, that's where governments can step in and provide that fixed price over a long period of time to reduce the risk and allow the learning curves to kick in. And so I would sort of make an appeal to say that, for too long, I think, as innovators and founders, throughout human history, we've sort of taken the market at face value and said, these are the rules that we get to color in. But what I think is so exciting is, now at this stage, knowing what we know about climate and the challenge that lies before us, we all, even if we're working entirely in the private sector, need to be policy entrepreneurs. Because at the end of the day, carbon removal it's a cost. It's something you need to pay for. So we need government to put that price on carbon removal, provide that incentive. And this is why, companies like Climeworks have people who work for them full-time just on policy. And so I think that's going to be so important. So I think all of us, all of you, can think about ways to start to craft and tell policymakers what you need. And that's something we'll be doing at Carbon Gap. So, come help us, come join us. We need these deployment incentives. And Europe is, most likely the region where we can begin, as well as North America.
Thank you, Eli. Julie, a reaction maybe on how policymakers can help the industry to grow?
Yeah, I mean, I think we've said it multiple times, right? Today, the market is voluntary. Voluntary from the company who pushes supply and voluntary from company who create the demand. So I think it's just the right time to drive this growth even further and in a even further exponential way, right? And in some sense, part of it is driven by country or region competition, which at the end of the day, I don't think any of us mind as long as it's drive it in the right direction. We've seen a lot of efforts from the US and then the European Commission as well. So I think we're really looking forward and welcoming this in order to be a strong network of support to accelerate that growth. So
absolutely.
Hopeful, optimistic, otherwise we wouldn't be trying to solve climate.
Absolutely. Thank you, Julie. Bryony, maybe do you want to comment on what the UK is doing on carbon removal and on the policy and other dimensions?
Yes, I'm happy to. And I think one thing is to just be clear about targets, right? At the moment, we have this kind of net zero by 2050, but it's, as Eli said, it's a mixture of reducing emissions and then compensating for what's left. And that can leave you a little bit unclear as to what's the size of both markets. And I think increasingly countries and indeed companies are going to be asked to be more explicit about what portion of that is a removal portion. And you could start to set targets for that. And the more explicit we are, the more clear it will be then for those people innovating into the sector that there's a market to go for. The renewables costs came down partly because we gave rewards, but we also set targets for their deployment because otherwise the maturity of the energy market would have just kept them out. And this is harder because you're not building something that's got a saleable unit of output. You're not selling electrons to people who need electricity. It's a waste disposal industry, really. And so it's going to have clear targets, clear government direction for it to then grow into that. And I think the UK is at the point of being able to really now start to articulate a specific goal for the carbon removal element, and that will be helpful as long as we don't treat it as an excuse to not emit, to not reduce emissions, or we just make these targets that they're easily met and then we just leave it at that. We should constantly reviewing and implementing dynamic targets that help us to invest more and more so we don't just rest easy and assume it's all done. So I think that's one thing the UK is doing. We're also investing in lots of research and development to get things out of the lab and into the market. So we've got to get a bit clearer about the articulation of the targets.
Thank you, Bryony. Clea, maybe a few words about what's happening in the US on the policy side as well.
Yeah, sure thing. I mean, the US has a lot of history around, well, oil and gas, but specifically actually something called CO2 enhanced oil recovery, where CO2 has been used as a form to further enhance the amount of oil that you can produce from a reservoir. So there's actually there's quite a bit of expertise around moving CO2 around. There are pipelines, there are CO2 transportation pipelines, there are injection wells. That said, there is a tax credit in the US called the 45Q, and most recently that has been proposed to be updated to value carbon removal direct air capture specifically, where CO2 is sequestered in deep geological reservoirs at $180 per ton. That's a pretty high price, and it's much higher than it was before, considered around $50 per ton. The state of California has something called the Low Carbon Fuel Standard that also incorporates carbon removal, specifically direct air capture, as an opportunity to mitigate emissions from transportation. That's valued at $200 per ton. The Build Back Better bill, as well as the infrastructure bill, each have portions of funding that are attributed specifically to direct air capture and carbon removal at large. So, I mean, there are a lot of things. I think at some point we wanted to talk about gaps and things that are still need to be de-risked. I think a big portion of that is actually CO2 storage, where there is expertise, but there isn't really an adequate regulatory oversight on CO2 storage. That is not a burden that, in my view, should be put on startups, at least not a burden for ensuring that stays there for several decades, if not hundreds of years. So we do need to figure out what kind of policies we put in place for that.
Thank you, Clea.
Maybe just one thing, building on that, that's from Climeworks history, but we often think about policy as like government instruments or institution instrument. I think one of the other things that made a project like Orca possible is the local support and the local public support that CarbFix, our partners, has received, similar to Climeworks, a bit more than 10 years ago, by thinking about this process that actually replicates nature. So I find very interesting what you said, Anna, Bryony, in terms of inspiring ourselves for nature, but enhancing that. But anyway, so just my point to say that policy goes also beyond that, and making sure that the right ecosystem for innovation are also locally relevant and driven, because only the meeting up of the direct air capture technology of Climeworks combined with this local company beneficiating from this very unique landscape made this project feasible in a very rapid manner, in a way. And I think that's another point that's very important to keep for every country in mind.
Absolutely, Julie. And so I'm looking at the questions from the audience, and remember, you can use the Slido to ask questions for the few minutes we have left together. So one question I think is very spot on. When will there be global homogeneous criteria for additionality, permanence? Basically, it's a question of the standards for carbon removal. I don't know who wants to take that. Maybe Eli? When will that exist? It can't come soon enough. I think there are two opportunities, and just to, Clea did a great job earlier of summarizing the fact that this is sort of a multi-criteria problem. A carbon removal credit, has multiple criteria of quality. That could be whether or not it's additional, whether or not it induces indirect carbon leakage. That's where you do something in one location and the effect leaks into another. They just produce palm oil in another country, for example. There's the durability of the storage, which is so important because carbon in the air persists basically forever. And then, of course, there's the co-benefits. Is this providing local jobs? Is it preserving ecosystems? All these other things. And so we need a system for rating all these criteria in a really clear way. I think there's two opportunities for first of all, the voluntary carbon market is taking stabs at this. Groups like Puro are actually going out there and just on their own creating standards. And that's great. That's really exciting. But ultimately, we do need government to lead here because we need this. There needs to be trust in this process. I would also add that we need to make sure that there's a very diverse set of voices in the conversation about standards, because even if the technology and the IP and the investors are largely in Europe, North America, East Asia, a lot of the projects might be deployed in other countries. That's the great benefit of having a global commons for an atmosphere. So we need to make sure that we think about environmental justice and including the voices of people that are going to be hosting these projects on their soil, if it's reforestation, soil carbon sequestration, et cetera. And sorry, to answer the question, the US is going to be doing this. They're going to be purchasing, there's a plan for the US government to actually be a procurer of carbon removal. So therefore, they will have to create such standards. And I bet on them to make some pretty good ones. Likewise, the European Commission is on the cusp of launching a big public consultation, which we'll be participating in, to establish CDR, a certification scheme for incorporation into the EU ETS by 2030, which is a little bit far away. So what are we going to do for the next 8 years? So that's the question. So there's progress afoot, but we need to move quickly.
Well, the obvious place for that to be sorted out is at the UN level, right? I mean, we just had another conference of parties, the 26th such conference. They don't talk about these issues, and yet they should be. They should be sitting down and working out what common standards we need globally to enable this market to develop. And it's upon all of us, France, UK, all the countries that turn up at these conferences to make these conferences focus on the things that matter. And this is one of those topics. So if the UN doesn't pick this up, it will be really negligent and in its task of trying to make this a global solution. So it needs to be fed into that process.
Fully agree. Thanks a lot to both of you. Another question which I find very interesting because it's the first one I see it, and it's probably an investor asking it. So the question is, at some point, we can hope that maybe we won't be needing CDR anymore because emissions will have been reduced like very, very low. How do we solve the decreasing marginal value of CDR in such a scenario?
Yeah, I'll pick that one up at least a little bit. Well, I guess, I mean, one, to Eli and Bryony's points earlier, net zero inherently means that you probably are emitting some CO2 still and that you need to make up for it by actively removing it. So there's still some portion of the market there. The other thing that I'll put a plug in for that I think is extremely exciting is around CO2 utilization. So while CO2 utilization is not a form of, in most cases, is not a form of permanent carbon removal, it is a very interesting market opportunity and accelerant from a financial standpoint for carbon removal and direct air capture solutions. And it can also be a very important source of reducing emissions. And by that I mean that converting, essentially everything around us is made of carbon. We are made of carbon. And converting CO2 into those pillars and into those things that we every single day rely on, whether that's food, chemicals, physical structures, there's a lot that you can do with CO2. And once you start really honing in on that industry and you have significant scale of carbon removal, there's no reason why you can't turn that into value. And people are working on that today. Again, for the same reasons those technologies are starting to become economically viable. I didn't even mention fuels, and that's a really big one. So.
Thank you. I would just answer that in a slightly different way, which is the assumption in the question is that, well, as soon as we stop emitting, we'll be fine. But that is not the challenge facing us. We are dealing with 100 years of emissions at extraordinarily high levels that we're going to have to counteract. And because of those hundreds of years of emissions, the biosphere itself is going to potentially become a source of greenhouse gases. So nature will go from being our best friend to our complete enemy in this fight because it will start producing more methane, it will start releasing CO2 itself. So we will be having to compensate not just for our own man-made emissions, but for the biogenic emissions that are now released because the world is going to heat up and that will release more greenhouse gases. So there's no loss of marginal value of this technology. It will be necessary for at least the next 100 years, probably the next 1,000 years.
Thank you, Bryony, Clea. I mean, I would have many more questions. We could go on and on for hours about carbon removal, but we've reached the end of our time. So I want to say thank you to all our speakers. It was a fascinating conversation. Thanks, everyone, for following this conversation on CDR with us. And yes, let's get up to work and remove the first gigaton very soon. Thank you all, and have a great afternoon.